Hello guys, so we are going to continue our discussion with respect to derivative. Already in our previous video, we came up with this specific formula of how to calculate a derivative at a specific point by drawing a tangent and calculating the slope of that tangent. And we understood that this was the formula that was specifically used, where we also use limits. In this video, we are going to probably do a problem statement wherein we'll try to find a derivative at a specific point. So already the formula is written on the right hand side. So let me do one thing. Let me quickly draw a diagram over here. So let's say that this is my entire coordinate system. Okay, I will try to show it over here. So this is my x coordinate, this is my f of x coordinate. Okay, now let's say that I have, for my problem statement, I have this kind of curve. Okay, I have just this kind of curve, or let me just draw it in a more easiest way. Let's say that I have this. Okay, I'll try. Come on. I just want a parabola curve like this. Okay, perfect. This curve looks perfect. Okay, now my aim is that, and let's represent this curve is basically given by the equation f of x is equal to x square. That basically means for every x coordinate, let's say this is 1, this is 2, this is 3, right? So what we are going to do in order to calculate f of x, I just need to square this. So when my f of 1, so if I probably go ahead and calculate f of 1, it is going to be 1. If I calculate f of 2, it is going to be 4. When I calculate f of 3, it is nothing but it is going to be 9. Okay. Now let's see that how to go ahead and calculate this specific derivative by using this specific equation. Okay. And that is what we are trying to do over here. Okay. So let's consider that I have a data point over here. This is my data point. So for this data point, what I need to do, I need to probably draw a tangent. So this will specifically be my tangent. And once I calculate the slope of this, I should be able to get the derivative at this specific point. Now, let me go ahead and first of all, in order to calculate this, let me first of all try to find out and obviously we are going to use this particular equation, right? So let's consider this specific point. So let's say that this point is denoted by x. Okay, and what we are going to do is that we are going to take another point over here. Okay, like how we specifically do it for the secant line. And if I go ahead and see, this is nothing but this is my x plus h. Okay, and as I've already told you, right, initially, whenever we have this kind of curve of line, first of all, we'll try to draw secant line, right? Like this. Then what we do, we try to move this entire points nearer to this x value, right? That basically means we need to move from here towards this x. That is the reason we have used limit h tends to 0. Okay. Now for this x value, first of all, we'll try to find out what is my y value. Y value is nothing but, if my x coordinate is having an x value, y is nothing but it is going to give me x square. And similarly for x plus h, this is basically going to give me x plus h whole square. This is my f of x, right? I'm just replacing x with x plus h, so it is becoming x plus h square. Okay. Now when I have this all the information, let's go ahead and apply in this formula, right? So my f dash of x is nothing but, here we are going to replace limit h tends to 0. Okay, what is f x of x plus h? F x plus h is nothing but it is this value, right? Because we are going to apply this specific function. And let me also denote what this coordinate is, right? So this coordinate is nothing but x comma x square, right? This coordinate is basically specified in this. This coordinate is specified by x plus h comma x plus h whole square, right? So I hope you're able to understand this. This is my x coordinate, this is my y coordinate, this is my x coordinate, this is my y coordinate. Okay. And here, now let me just go ahead and write what is f x plus h? It is nothing but x plus h whole square. So here I'm going to go ahead and write x plus h whole square minus, I'm going to have to subtract with f of x. What is f of x over here? F of x is nothing but x square. This is what is my f of x. This is nothing but it is my f of x, and this is nothing but this is my f of x plus h, right? So here I have this, and when I use f of x, it is nothing but this value is x square. And then we are going to specifically divide it by h. What is h over here? right? Just try to see this. Again, this is my h value, right? So here I'm going to replace this by h. Okay, h is same, right? Now, once we have this, let's go ahead and do this calculation. So again, I will go ahead and write f dash of x limit h tends to 0. And here I'm going to specifically write h square plus 2xh plus h square minus x square, because see, this is just like a plus b whole square. So I can write x square plus 2xh plus h square minus x square, right, divided by h. So now this x square and x square will get cancelled. Okay. And here, what I am actually going to do is that I will just go ahead and write like this: limit h tends to 0. And here we will just take h as common. Let me go ahead and write 2x plus 1 divided by h. Okay. 2x1, sorry, it should not be 1, it should be h. 2x plus h divides by. So this will be there. And finally, I will be able to get limit h tends to 0. It is nothing but 2x plus h, right? And since h is tending towards 0, right, I can replace this h with 0. So I'm going to get the value as 2x. Now, what is this 2x, right? So 2x is nothing but my f dash of x, right? F dash of x, that basically means the derivative of x square is nothing but 2x. And if you just remember from the college, right, I hope everybody knows what is the derivative of x square, right? So a normal form of derivative, if I have x of n, if I try to find out the derivative, it is nothing but x n multiplied by x of n minus 1. So this is the formula, and that is absolutely true. Since I had the equation f of x is equal to x square, when I'm trying to find out the derivative, it is nothing but 2x, right? And you can see over here, this is the value that I'm able to get. And I just did the same thing from this particular curve. I'm trying to replace all the values over here, and I'm trying to find it from you. And I'm getting the exact same information, right? So if this data point x was, let's say, if this data point x was 6, if I want to probably go ahead and see with respect to 6, right, over here, I can just go ahead and replace this value over here for this, right? So I will show you with the numerical value, but just to give you a perspective over here, the derivative of x square is nothing but, it is nothing but 2x, right? And this is how you basically go ahead and calculate for any specific point what will be the derivative. And again, in mathematical things, right, mathematically, right, we also write something like this: derivative of, so we specifically use this symbol, derivative of f of x with respect to x, right? It will be nothing but derivative of x square with respect to x. So this is nothing but 2x, and that is what we are getting over here. So this way also we actually write this. Okay, we'll discuss more about the derivative. We'll solve some problems just by taking one data point, and then I will still show you whether this entire things that we have got. But in short, what we have done is that we have just found out, right, this one, f dash of x is nothing but 2 of x, right? And this x is nothing but f dash of x square is equal to 2x. This I have just written f dash of x, but this has to be f dash of x square, right? And finally, I get this specific output. Now, what we are basically going to do, let's take a very simple example. Let's say that if I have a curve, okay, and we'll take the same example. Let's say this is my curve. So if I have an x value, let's say 7, right? And with respect to 7, I should be getting over here as 49, because my function is nothing but f of x is equal to x square, right? So this coordinate that you're seeing, right, it is nothing but, it is 7, 49, okay? Or let's take some other number. So let's say that I'm going to probably take 9. So let's say this is my 9, and here I'm going to get 81. Okay, so this coordinate that you have is nothing but 9, 81. Now, if I want to find out what is the derivative with respect to x, it is very simple. I will just take 2 multiplied by 9. So 2 multiplied by 9 will be 18 at this specific point. So what we are basically trying to calculate, what is the derivative, right? What is the slope? What is the derivative at this specific point when your x value is equal to 9? right? And that is what we have actually done over here, because at the end of the day, when we try to find out the derivative, it is nothing but 2x. So I'm just going to multiply 2 multiplied by 9, which I'm actually going to get it as 18. So I hope you are able to understand this particular video. This was it from my side, but I hope the entire derivative things which we have actually discussed with respect to limits, with respect to the derivations, and with respect to slope, it is clear. And if you solve more and more examples, you'll definitely be able to get a very clear understanding with respect to this. So yes, this was it from my side. I will see you on the next video.